What's up? I'm going to be practicing my basketball skills today because I've been learning how to play basketball. I don't know too much about basketball, but I do know a thing or two about projectile motion. So I'm going to see if that can help me today with making my free throw shots. With basketball, we're talking about 2D kinematics. 2D meaning two-dimensional. Because our projectile, the ball, is going to be moving two-dimensionally. It's going to be moving horizontally and vertically. The ball is going to be moving both in the X direction and in the Y direction. So let's see what factors affect two-dimensional projectile motion so I can get the ball in the basket. Okay, I'm gonna give you a basket full of knowledge here, so be ready. So free throws are a perfect example of projectile motion because my hands give the ball an initial velocity, but once I let go, there are no other forces acting on the ball except for the force of gravity, which is what projectile motion is. So yes, we are on Earth and there's air, but in all of the problems that you're gonna do, we neglect air resistance. So we don't care about the air, we pretend the air does not exist. Okay, so I've got a person shooting a basketball into the hoop. The ball has an initial horizontal position, x0, and for all the videos, it is going to be the same distance away horizontally from the basket because I start at the free throw line for every single video. The ball has a starting height, or y0, so the ball's initial vertical position. We need a reference line for 0, so I'm going to call the ground y equals 0. The ball's going to be given an initial velocity, v0. Now this green line is going to represent the horizontal, so it's just parallel to the ground. The ball is going to have a launch angle theta, and that angle theta is between the direction of the speed and the horizontal. So this angle could be like 45 degrees above the horizontal, and that's what that means if this green line is my horizontal. We can break the initial velocity into its horizontal and vertical components. So that red arrow is the horizontal component of the initial velocity, and the purple arrow is the vertical component of the initial velocity. Sorry if that was kind of quiet. I'll try to project my voice more. What is the ball's path going to look like? Any 2D projectile is going to look something like this. Another word for the path is trajectory, and because the path is curved, we call it a parabolic curve or a parabolic trajectory. The goal for me is to get the ball into the basket. What that means is that along its path, the ball has to pass through this position right here where the hoop is. So we're going to look at how does the initial speed, the launch angle, the starting height of the ball, how does all of that affect the path that the ball takes? And so we can look at the things that you can adjust so that you can get the ball in the basket, right? There is a pole here, so the ball is going to bounce off of it often in the videos. But if there was no pole here, the ball would continue along this parabolic path and at some point hit the ground. So this horizontal distance or horizontal displacement, this distance here is the ball's horizontal displacement. The ball's going to hit a maximum height. We're going to call that y max, and that is the maximum vertical displacement. And right before the ball hits the ground, the ball is going to have a speed v. Notice this one was v0, initial speed, and this one's just v for final speed. And that is the speed right before the ball hits the ground. Let's break down what's going on in a two-dimensional projectile motion problem as an object flies through the air. So you have something launched with some initial velocity at a certain angle theta, that's the launch angle. It has a horizontal component, an initial horizontal speed, and an initial vertical speed. I want to talk about what's happening to each component of the speed as the ball flies through the air, as well as this thing called acceleration. Let's talk about vertical stuff first. At any point during the ball's flight, the force of gravity is acting on the ball downwards. What does that mean? Well, whatever's flying through the air is going to have a downwards acceleration because the force of gravity is acting downwards. Now, the force of gravity accelerates all objects on Earth at the same acceleration. So every object flying through the air on Earth has the same vertical acceleration due to gravity, which is 10 meters per second squared, or 9.8 if you're fancy. We represent that with the letter G, that is the acceleration due to gravity on Earth. Now remember, an acceleration is a change in speed or a change in direction. And the acceleration due to gravity is going to do just that. It is going to change the vertical component of the speed, and it is going to change the direction that the object is moving. So the only thing accelerating the ball is force of gravity. Gravity is accelerating the ball in the vertical direction, which is what causes the ball to fall to the ground. So the only thing that is causing the ball to change its direction, to go in that curved, arced pattern, this parabolic pattern, is the force of gravity. The force of gravity acting in the vertical direction is what is causing the ball to make that curve. The force of gravity is accelerating the ball down towards the ground. The object is still moving horizontally the whole time. So that's why the ball doesn't just take a dive straight towards the ground. It follows this curve because as it's moving horizontally, gravity is pulling the ball towards the ground, causing the direction of the motion of the ball to change. Hopefully some components of this are making sense. Hee hee. Now, if you were in the vacuum of space and you launched the ball would keep moving in a straight line. So if I launched the ball this way, in outer space, the ball would keep moving in that diagonal line forever and ever because there would be no force to change the direction of its motion. So vertical acceleration affects vertical speed. So what happens to the vertical speed as time is passing? The ball is going to slow down vertically, come to a momentary stop vertically. At the very peak, it is not going to be moving vertically, and then it is going to speed up vertically and come back down. Just like if you threw a pen up in the air, right? You throw it up, it slows to a stop momentarily, and then it turns around and speeds up in the downwards direction. The vertical component is pointed upwards at the beginning, but gravity is pulling downwards. So gravity is going to try to change the direction of that vertical component so that it also points downwards. The vertical velocity as time passes is going to get smaller and smaller until at the peak the velocity vertically is equal to 0 meters per second. Because it was moving upwards and now it's going to turn around and go back down, which means for a split second it has to come to a stop. Then what happens is the projectile starts moving towards Earth again. So it starts speeding up in the negative direction. It starts speeding up towards Earth. So now the vertical component of the speed will be pointed downwards. And then it's going to go faster and faster and faster, which means my arrow is going to get longer until it ends up with the same vertical speed that it had at the beginning, except pointed downwards. So the speed at the end is so the vertical component of the speed at the end is equal to the vertical component of the speed at the beginning. It's just pointed in the opposite direction. So what caused this to happen? The acceleration due to gravity. Now what about the horizontal component? Forces cause an acceleration. Once nothing is touching the ball, the only force acting on it is gravity. Gravity acts vertically. So there are no forces acting in the horizontal direction, so there is nothing to change the speed of the object horizontally. What does that mean? The horizontal component of the speed is not going to change. So as the ball is moving, the vertical speed is changing, but the horizontal speed is remaining constant, which means at the very top, the ball is moving only horizontally. It is not moving vertically, only horizontally. It's moving horizontally with the same horizontal speed that it had at the beginning, and so that horizontal speed stays the same because there is nothing whatsoever to change it. There's no force to change that horizontal speed. In a projectile motion problem, one of the most important things to note is that the acceleration in the x direction is equal to 0 meters per second squared. There is nothing accelerating the object in the horizontal direction,
which means the horizontal component of the speed does not change.
Okay, and what about the mass of the ball? Does that matter? So if I used a volleyball, would I have to change how fast I'm throwing the ball, or how high I am off the ground, or the launch angle? Would that change the motion of the ball if I used a volleyball, which has less mass than a basketball? Well, those of you who play sports might say yes, but that's because of air resistance, because we're on Earth. That does affect the motion of the ball a little bit. But if you neglect air resistance, the mass of the ball has no effect on the projectile motion, because once I let go of the ball and I give it its speed, the only force acting on it is the force of gravity. So it doesn't matter what mass of a ball I have, the acceleration due to gravity in the vertical direction is going to be the same for anything. So if I have two balls of different mass, I start at that free throw line and I give both of them the same launch angle, the same starting speed, the same starting height, then both balls can make it in the basket and both balls will get to the same place.
So the key takeaways are: the mass does not matter. Doesn't matter how heavy, how light the object is, whatever. It doesn't affect the path of the object. Acceleration in the vertical direction of any object on Earth is 10 meters per second squared, always. That is the acceleration due to gravity on Earth's surface. When something is falling or flying through the air under only the influence of gravity, no other force is acting on it, the acceleration in the x direction is 0 meters per second squared. Super key. And from that we get that the horizontal component of the velocity does not change. Whatever the initial horizontal component is, the object is going to maintain that as it is flying through the air the whole time.